Each truck comes with a float gauge. They're marked in 50-gallon increments. Special message on the float gauge itself says, do not fire the burner below 400 gallons. This gallon number can change from truck to truck based on the size of the tank. It's very important that you know and understand that liquid level in order to fire the burner at the appropriate level. If you fire the burner below that level, you can cause an explosion. On the side of the tank is the thermometer well. The thermometer well is a tube that runs down into the tank. It's sealed to keep the asphalt from leaking out. Inside the thermometer well we put hot transfer roll. The hot transfer roll conducts the heat from the wall of the thermometer well to the thermometer. Use caution when pulling the thermometer out, as the temperature of the hot transfer roll is also the same temperature as the asphalt in the tank. So if you're running hot asphalt and it's 350 degrees, so is this hot transfer roll, so you can run the risk of getting burned. On the thermometer is marked from 50 to 600 degrees. Again, use caution while opening the thermometer well, as also moisture can build up inside there, and in the event that you're shooting hot asphalt, when you first go to open this up, it can actually spray out a little bit at you because of the water buildup and the steam that's produced by the hot transfer. So be careful. On the side of the tank, we have a hose trough. Inside of it is a 10-foot long, 2.5-inch rubber asphalt hose. This hose is connected permanently to the A valve. You can remove it, but it's not necessary in the course of day-to-day operations. The hose simply comes out of the trough. You can swing it around and attach it to the truck without disconnecting it from the A valve. At the end of the cycle, place the hose back into the truck and you're ready to go. The A valve is a manual valve. Once you've hooked up your truck and you've selected the right valves on the valve selector, put your pumping forward and open your A valve. On the back side of the A valve is a load strainer. You see these 4 bolts here? If you remove this valve, there's a screen behind it, which is a 1/4-inch screen that we use to strain the intake side of the pump. This is a 1/4-inch screen, and it's just made to catch nuts and bolts and cell phones and hats and stuff like that. Located in the back here is the bar screen. This is a finer screen that we use to keep from the nozzles from getting plugged. The product pump on the eTack is a BC300, which is 0.3 gallons per revolution. It's smaller than our standard BC501. Just like the new BC501, the BC300 is relieved in both directions, a new feature with BearCat pumps. This is the relief valve. There's one identical to it on the opposite side. You can't see it from here. This tube on the outside of the pump is a case heater. The engine coolant from the radiator circulates through the pump and warms it up. This hose is an extension of that radiator coolant. It comes into the pump, circulates through the end plate, comes out of the end plate, goes through the main casting, goes back into the other end plate, and then on the other side it actually goes through the loading and unloading. Loading and unloading with the asphalt distributor is done with the A valve and the D valve, depending on what direction you want to load or unload. Depends on which direction you run the pump. Normally this product pump forward is in the bottom, out the top. So if I wanted to transfer with this pump, I would hook the A valve to one tank and the D valve to another tank, and if I loaded in forward, I would load from the A to the D. If If I wanted to go in reverse, I'd be going in the top of the pump and out the bottom. So I'd come in through the D valve and out through the A valve. In a normal spreading application, the asphalt comes from the tank, it goes into the back side of the strainer box, into the bottom of the pump, it circulates into the manifold on top of the pump, into the bar strainer. In front of the bar strainer is the spread valve. If you're just loading the truck, the spread valve is closed unless you're loading the truck through the spray bar. With the master switch in the off position, asphalt comes through the open main tank valve, comes into the bottom of the pump, through the strainer box, into the bottom of the pump, and forward, out the top of the pump, into the manifold on top of the pump. The bar valve is open. The tank circulate valve is closed. Asphalt comes through the bar strainer. The equalizer is closed, so its only path is to come out the left bar feed hose. It travels down the left bar feed hose, feeds into the main spray bar. The spray bar has several passages. It has a passage on the back side of the bar that feeds the top of the bar. This passage is divided in half, so the asphalt this tube can only come halfway down the spray bar. It feeds in to the top of the spray bar. It then travels out to the swing joint. The swing joint is divided into an inner and an outer core. So it travels out the outer core, comes up into the wing. The wing is also divided in half, so the asphalt travels down this half of the wing feed tube. You notice this weld running along the bar. The asphalt travels out the top of the bar, down the bottom, back up the wing feed tube, goes through the inside of the swing joint and feeds into the bottom of the spray bar, goes all the way across the spray bar, and vice versa. It goes in and out the wing, all the way out, back down the wing, and then back up the bar feed hose. The equalizer is closed, so it can't go back into the bar strainer, so it goes up the spread circulate line to the spread circulate valve. It's open and it feeds back the tank. It circulates round and round. When you turn the master switch on, the equalizer opens, the spread circulate valve closes. So the asphalt comes out of the top of the pump. It feeds both the equalizer bar feed line and the left bar feed line. Goes out both bar feed hoses down to the spray bar. It feeds the spray bar in two places and spreads it out on the ground, and no asphalt returns back to tank. This is a positive displacement pump. We turn the pump at appropriate speed to achieve the spread rate we're after. When you're spreading asphalt, all the asphalt from this pump goes on the ground. There is no bypass valve. The pump is relieved in forward and reverse, so if anything were to be plugged, the pump just relieves internally. The spread circulate valve is a true on and off valve. There's no bypass. Asphalt comes out of the main tank valve, goes through this 3-inch pipe to the bar strainer, feeds in the bottom of the pump, out the top of the pump, into the upper manifold. The bar valve is open. Asphalt circulates into the bar strainer. The equalizer valve here is closed. Asphalt goes out the left bar feed hose, circulates through the spray bar, comes up the right bar feed hose, comes back to here. The equalizer is closed, so its only route is to go up the spread circulate line to the spread circulate valve, which is open, and it goes back to tank. When you turn the master switch on, asphalt comes in through the bottom of the pump, top of the pump, into the bar strainer. The equalizer is now open, so it feeds both the right and the left bar feed hose at the same time. It goes down both hoses and feeds the spray bar in two different places. Turn the master switch back off and it goes back into bar circulate. In heat circulate mode, you're circulating the asphalt in the tank without contaminating the spray bar. The asphalt comes in through the main tank valve, goes in the bottom of the pump, out the top. The bar valve is closed, the valve to the bar strainer, so its only path is to run up the tank circulate line, and it goes through the F valve, which is open and back to tank. So it just circulates around and around in the tank through the pump. When you flush the spray bar, the main tank valve closes. The valve up here, I, opens. So that the asphalt is pushed through the normal circulation path, through the bar strainer, out the left bar feed hose, goes through the spray bar, up the right bar feed hose, and returns the asphalt to tank through the K valve. It does this for a period of 5 or so minutes until all the asphalt is purged from the spray bar. The second stage is the K valve closes, the I valve closes, and the H and the J valve opens. This allows flush fluid to be taken in through the bottom here. It circulates all the way around the spray bar and is returned to the flush tank through the J valve. It circulates that for whatever time you have set up in the computer to flush the bar. The third stage is the H valve closes. It continues to run in forward. The J valve remains open, and the I valve opens to allow air to come in to help the pump push the flush fluid out of the spray bar and back to the flush tank. Once you remove the hand wand from the holder, make sure that the valve is closed. The way you determine that the valve is closed is that it's perpendicular to the wand. This is open and this is closed. Once you have the valve removed from the holder and the valve is closed, you open the applicator valve. There's a valve located on top of the pump that opens the asphalt to the hand wand. With the truck in normal circulate mode, you should have ample amount of product flow in order to use the hand wand. If you need more flow, then switch to manual in the cab and increase the pump speed as needed to produce the amount of spray you want to spray with the hand wand. Again, close the valve. Once you're done, place the hand wand back in the holder with the valve closed. Reverse the pump. With the pump in reverse, go ahead and open the valve a couple times. You'll hear it sucking air and purge the asphalt from the line. At the end of the cycle, it's actually a good idea to take a coffee cup full of diesel and just go ahead and suck that cup of diesel up while the pump is still in reverse. Just as soon as it sucks up into the cup, shuts it off. That tells you that it's going to stay in the coiling of hose on the back of the distributor, and that'll give you a lot better start the next time you use it. After you're done with that, shut the valve off. You can put your pump back and forward. If you purchase the propane heating option, the propane tanks are located on the side of the truck next to the batteries. The valve to supply the propane to the burner is right here. These valves must be on in order for the burners to light. The burner exhaust pipe has a lid. This needs to be open before you light the burner. An optional propane system has a basal valve on the side. Once you open the basal valve, this will supply gas to the burner. The burner has a regulator. It's normally factory adjusted, and then there's a switch on top of the burner. It's very important that you read the placard. Caution, tank will explode if tubes are not covered when heating. Lower burner must be on for upper burner to operate. That's an optional if you had two burners. Normally we wire it so that the first burner has to be on before you can light the second burner. Again, pay attention to your float gauge. It's marked on the float gauge that liquid level that needs to be achieved before you light the burners. Along the side of your hose trough is a cable. This is a gas emergency shutoff cable. Anytime you have a problem with a propane fire, you can shut the base hose valve off. In order to fire the burners, you're going to have to turn the base hole valve on. So you have to flick this valve up. At any time, I can turn the propane system off by pulling on the cable. When your asphalt distributor is all warmed up, your bar feed hose pivot points should have good flexibility. Once the truck's warmed up, these joints should move back and forth with ease. If they're too tight or they're seized up, all the flex happens in the bar feed hose, and this can decrease the bar feed hose life. So, it's a good idea every day to walk around your truck after it's all warmed up, because they won't move when it's cold. Just make sure that these bar feed hoses are moving freely. When transporting the spray bar, the wings should always be up and pinned and the bar last. When you get to the job, you remove the pins, unlatch the spray bar, from the back of the distributor, you can operate the spray bar lift, swing, and wing raise functions. The lift is raising the spray bar up and down. The swing switch moves the bar left and right. Three nuts fasten down the lid. Access the tank. Dome lid does not have to be opened under normal operations while loading, unloading, or spraying asphalt. Over here is a 3-inch vent that vents the tank to the ground. This is a permanent vent, so there's no need to open the dome lid to load or unload. Be sure to tighten down the dome lid anytime you travel. On the front side of the dome lid is a 3/4 inch pipe that bends down towards the tank. This is the vent for your flush tank. On the back side of the vent is an air tube that runs to the back, which is the air intake for your flush system. When the pump goes into flush mode, the first stage of the flush is to purge the spray bar of asphalt. This opens a valve that allows it to suck air in this line and blows the asphalt out of the line back into the tank. On this side of the vent is the drain for the dome well. This drains the water out of the dome well as well as any kind of asphalt that might accumulate up there. Inside that is where we store the dipstick. When we calibrate the float gauge on the side of the tank, we also calibrate this dipstick. Each dipstick is specifically assigned for the tank that it was calibrated with. This is a 100 amp alternator that supplies a 48 volt power to the electric pump. An optional 200 amp alternator is available if you get electric heat. And the only real difference when you look at it is that the alternator is twice as long. It's belt driven off of an additional pulley that's added to the fan pulley. It has its own belt tensioner. Underneath your flush tank are your batteries for your 48 volt. 4 12 volt batteries that supply the 48 volts to your product pump and other functions on the back of your spray bar. On the right hand side of your distributor is the flush tank. It has 3 different functions. It contains flush fluid to flush the spray bar. There's approximately 20 gallons of fluid in this tank. In this section is the wash down tank. whatever fluid you want to spray the outside of the spray bar down with the wash down hose. This is where that fluid is held. And then in this section up here is a reserve air tank for your system. If you open the cap here, there's a dipstick to tell how full the tank is of flush fluid. And you also use it to determine how thick your flush fluid is getting. The more you flush your tank, the thicker the asphalt's going to get. And at some point you want to change your asphalt. So you use this little dipstick to determine that. This is your diesel washdown tank. It has an air pressure valve. This valve supplies air to the tank. This is what forces it out the end of the hose. This valve here is a dump valve, so when you go to fill this tank, you have to release the pressure off of the tank. On the bottom of your auxiliary air tank is a drain valve to drain the water that builds up in the system. On top of your flush tank is a vent hose. This hose runs along the tank and it runs up to the top and goes inside the skin. It continues all the way up to the top of the tank, up to where the tank vents itself. All this is for is to vent the flush tank. On the back side of your flush tank, mounted on the back fender, is a washdown hose. It's a simple hose with a nozzle, and you use the valve to turn it on to spray. On the side of the eTack is the selector switch. This switch controls different functions for the spray bar. In order to use this valve selector, we have to first switch outside control on the main console in the cab. Once that happens, all the controls are switched to here. Otherwise, all of these switches are disabled. The first position on the valve selector is cab control. Anytime I go back into the cab of the distributor and I want to use the console, this has to be switched to cab control. Vice versa, inside the asphalt distributor or the valve selector has side control. So in order to use the side control, I have to switch that one to side control. The second position on the valve selector is load with pump valve A forward. This means hook your load hose to valve A on the back, put your pump in forward, cycle your valves, and then control the speed of your pump. To load the distributor using the first selection, load with pump, valve A. The A valve, the load hose is connected to the A valve. The load hose hooks to the transport. A valve is open. Asphalt comes in through the A valve, through the strainer box in the bottom of the pump, pumps in forward. Asphalt comes through the top of the pump into this manifold. The bar valve is closed, runs up the circulate line and goes through the circulate valve into the tank. That's how we load the truck. It's always a good idea at the end of your pumping cycle to turn this to zero. Zero for neutral on the pump direction. Close your valves. The second position on the valve selector is offload with pump valve D forward. This means we're going to offload the tank onto another one. We're going to hook the hose to valve D. We're going to run the pump in forward. So forward, open the selected valves, operate the pump speed. Offload with pump valve D forward. So we're going to offload this tank onto another tank with pump. Okay. The A valve, the big tank valve, is open. And the circulate valve is closed and the bar valve is closed. So the asphalt has nowhere to go but out the D valve. So this D valve is what you'd hook up to the tank you're offloading to. At the end of the cycle, zero the pump speed, neutral on the forward reverse switch, close the valves. Fourth position is gravity offload valve A. This is the position I'd use if I was at a hot plant and they were doing the pumping. This will gravity feed the asphalt through valve A into the plant. Once again, after you select it, open your valves. Now, because this is gravity, we're not going to do anything with our pump. The gravity offload valve A. So the big tank valve will open, and the asphalt will flow gravity through the bar strainer, out valve A, and through the load hose. So this is an option that you'd use if you're at a hot plant or if you're using another pump to suck the truck off. So you'd have your load hose hooked up to the hot plant or the transport or the other truck that has the pump. Now open valve A, the tank valve will be open and you can suck the asphalt out through the load hose. In the cycle, close the valves. Fifth position, load through spray bar with pump valve A forward. This means we're going to load through the spray bar, through valve A, we're going to run the pump in forward. So we're going to hook our hose to valve A, we're going to run the pump in forward, open our valves, control our pump speed. Now the reason that we want to use to load through the spray bar is if we had a wet truck and we wanted to dry it out and we were going to load hot asphalts, it's imperative that you load through the spray bar. This will knock any kind of moisture out of your spray bar and put it into the tank so it can boil off. You'll want to do this at a slow rate. So if you had a wet truck and you wanted to dry it out, I would say load in 100, 200 gallons or so, let it boil off, and then load slowly after that. Load through the spray bar valve A forward. So our load hose is hooked to the transport truck, valve A is open, asphalt comes in through the bar strainer in the bottom of the pump, pump is running it forward. The bar valve this time is open, the circulate is closed, so the asphalt goes in through the bar strainer. The equalizer valve here is closed. Asphalt goes out the left bar feed hose, circulates through the spray bar, comes up the right bar feed hose, comes back to here. The equalizer is closed, so its only route is to go up the spread circulate line to the spread circulate valve, which is open, and it goes back to tank. At the end of the cycle, stop the pump, neutral switch, close the valves. Sixth position, through pump transfer valves A and D. If I wanted to pump from a trailer to another truck and not use this tank, I can use the pump as a transfer pump. So I'm going to hook my hose to valves A and D and then open the valves. Depending on which direction I want to go, you'll be forward or reverse. Reverse will always be in the top of the pump, out the bottom of the pump. Forward will always be in the bottom of the pump, out the top. So I'll put it forward, control my pump speed. The through pump transfer utilizes both valves A and D. If you use the A for the suction, the load hose will be hooked to the tank you're pulling from. It'll go through the bar strainer, it goes through the pump, pumps in forward and out the D valve. Okay? In order to reverse this process, you can either just reverse the pump or you can use the D for the suction and the A for the outlet and run the pump in reverse. End of the cycle, zero the dial, neutral the switch, close the valves. The last position on the valve selector is empty the flush tank. And all this basically does is it opens the intake of the flush tank and allows you to pump whatever contaminated flush fluid is in the flush tank into the main tank. So we'll open the valves, run the pump forward, control the speed, leave it at zero, shut everything off. Back to cab control. Inside the valve box, or the valve selector box, is an electric fan that cools the motor controller as well as the motor in the back. The intake for the motor controller has a 12 by 12 household type heater vent screen that just keeps out the atomized asphalt and dust and stuff so it doesn't collect inside of the valve box on all your electrical components. it's imperative that the valve box cover be bolted down because it has to seal the air in and force the air down this tube to the back to the motor. The fan is thermostat controlled, and it kicks on and off. You'll hear it from time to time. But if this lid leaks, or if you take the foam off the back that seals the hoses that go in and out of the box in some kind of repair, it's important that you reseal it because it has to get that air to the motor and back. Result of loss of air, the fan kicks on right there. The result of loss of air to the motor will cause the motor to shut down. Inside the valve control box, are the nodes for the computer, relays, all your wiring, some of the major relays for the 48-volt system, your motor controller, and all your valve banks. Once again, if you get into this box, it's imperative that we seal it up. Note the rags on the back. We would have done some kind of repair on this truck while we're here. I just had it sealed up with the rags to test it because there was a major hole in the back and I was losing some of my cooling air for the electric motor. As soon as we get done with the repairs, we'll seal it up with foam. Once again, very important to get all these bolts put back in. Okay. On the side of the valve box is a 48-volt disconnect. This shuts off the 48-volt power to the system, so if you're wanting to work on the box or inside of it, you can shut it off. It's always a good idea to shut it off at night. That's on. That's off. This is a console for the BearCat eTack tack truck. Power switch is right here in the center. Hold it on a couple of seconds. The display will light up, say BearCat Manufacturing. Warning sign comes up. If product temperature is above 200 degrees Fahrenheit, ensure that the piping is dry. If there is liquid present, there is a risk of an explosion causing serious injury or even death. By continuing, you assume the responsibility of ensuring that the piping is safe. Normally, if you're shooting emulsion, this isn't a concern, but if you're going to shoot hot asphalt, anything over 200 degrees after shooting something wet or an emulsion, you need to ensure that the truck is properly flushed out. And by saying okay, you understand what you're about to do. So I'm going to press OK. Sometimes the OK moves from button to button just to keep the operator on his toes, so he has to think about the decision he's making. In the upper left corner is gallons per square yard. You can increase or decrease the gallons per square yard spread rate by simply pressing this button or up and down, and it will control the gallons per square yard in 1/100th increments per click. You can do this at any time when you're spreading or sitting still. Over here in the center are my wing lift controls. I can lift the wings up and down. Right wing up and down. To the upper right is the raise and lower of the entire spray bar, as well as the side shift for the spray bar. So this moves left and right, and this moves up and down. This is the master switch. The master switch turns on and off all of the selected valves at one time. So if we turn on all the bar valves, or one of them, whatever you want to do, when you go to spray, you hit the master switch and turn them off. The master switch has three positions: on, off, and ready. The ready light will come on when you hit ready, and what ready does is that whenever you're about to spray, normally with the master switch in the off position, the pump will be circulating at idle speed. By hitting the ready switch, what that does is it looks at how wide you're about to shoot. It looks at your spread rate, and the minute you start to roll ahead, the pump goes to the desired rate so that when you turn on the master switch, you're putting down exactly the right rate. In previous years, we went from circulate to spray instantly as you turn the master switch on. So the product pump had to go from the idle or circulate speed to whatever desired rate you were spreading in fractions of a second. This just ensures that you're going to spread the right rate when you hit the line and without any flooding. Below this is the selector switch. Right now it's in the off position. The first position to the left is spread heat. Anytime you operate this switch, it actuates the appropriate valves in the asphalt plumbing in the back to produce the desired effect. So if you're going to go to spread, it's going to spread and circulate. So it's going to open the tank valve, it's going to open the bar valve, and any other valves that it needs to get into spread mode. The second one down is load outside. Okay, this disables this panel so that when you go outside, you can operate the controls outside and none of these will have any effect, no matter what position they are. Circulate heat is the next selection down. As I switch this, you guys can hear the valves actuating in the back. They're all air controlled. Circulate heat circulates the tank and the pump while you're heating. It doesn't circulate the spray bar. This allows you to not get your spray bar contaminated while you're circulating and heating. Auto flush is the last selection on the list. Auto flush automatically flushes your spray bar. So at the end of the day, you can fold up your wings and turn all your valves off, turn your master switch off, turn your pump off, switch it to auto flush, turn your pump back on, and it will go into auto flush mode. What that does is it'll run the pump and valves, and it'll purge the asphalt from the spray bar. That is, it's running the pump and forward fast, and it opens an air vent to push air through the spray bar and push the asphalt out of the spray bar into the tank. The next cycle it automatically does is it valves the system so that the flush tank is open, and it'll circulate the diesel from the flush tank through the spray bar and plumbing and back to the flush tank for a desired length of time. This amount of time is adjustable. The last step is that it closes the intake for the flush tank, and it pushes all the flush fluid back into the flush tank and shuts down. You can all do all this while you're driving back to the shop. On the left hand side is our pump control. We got forward, off, and reverse. In normal operation, you're going to have it in forward. The next switch over is manual and CRC. In manual mode, I manually control the speed of the pump. In CRC, which stands for computerized rate control, the computer looks at the desired spread rate, the desired spread width, and truck speed. It runs the pump at the appropriate speed. To the right of this is an optional heat switch. This is 48 volt heat, which is an option on this electric distributor. It's a nice feature. The 48 volt heat can be operated while driving down the road. There's no open flame. It's all electric. The right of this is a beacon switch, turns the beacon on and off. Below this are all your bar switches. This is the left wing controls. The main bar, there's 8 feet, and the right wing controls. Up is on, down is off. Outside is the line marker, which is optional. Down is on at any time. Up is, it says master on the control, which means that just like these switches, it'll turn on with the master switch. So you have on with the master. These are your right and left wing markers. Right here about the middle of the panel is called the taper cut. You got 2 switches. They say out and in and out. This switch controls from the right to the left. This switch controls from the left to the right. And what this does is is that it allows you to shoot a taper and cut off your feet in consecutive order, so that you can shut the spray bar on and off from left or right without using these manual switches. In order for any valve in the spray bar to operate, you have to have both the in and out taper cut switches on and the manual spray bar switches. So if I was wanting to turn off my spray bar from the right to the left in 1 foot increments, all I have to do is, while I'm spreading, click this switch and it'll start shutting them off in sequence from the right to the left. Now if I turn them all the way off with this right taper switch, I have to turn them back on with the same switch. I can't turn them on with this switch, okay? Now if I wanted to shut off from the left to the right, I use this switch here and I turn them off, and they'll shut off in consecutive order all the way across the bar. This even includes the line markers. Now if you've turned off the spray switches or the spray valves with the taper cut switches, you can't turn them on with these. These are already on, but you have to have them both on. So we'd have to turn these back on the same way we turn them back off. Now I can shoot a taper the conventional way as well with the plain old switches. Same deal, master on, start turning your switches off. It's a good idea to practice turning these switches on and off all in consecutive order. You'll become a much better spreader operator the handier you get at controlling these switches. A lot of times when I'm about to shoot a radius, I'll actually practice this with my master switch off. I'll just practice the radius, or I'll get my fingers warmed up to the fact that they got to flip all these little switches. Now, I'm old school. I actually like shooting radiuses with these old manual switches. I haven't got used to the taper cut yet, and that's just because I haven't spent enough time in a distributor with the option of a taper cut. So I'm kind of old school, but I like to keep practice up. So still, good exercise. When you're sitting here nothing to do, practice turning these switches on and off in nice rhythm. Obviously, I need practice. Make sure they're all on and off. You want to make sure that you don't miss any. That's one of the worst things that can happen, and that's one of the good reasons for the taper cut. In the old days, it was common that as somebody was turning the switch on, they might miss one. Okay, I missed one right here on purpose. Well, that's going to leave a blank spot, which is going to be hard to patch. Okay, the taper cut eliminates that problem. I can turn them off in consecutive order. I can turn them off in consecutive order and not worry about missing a switch. This just gives the operator a lot more flexibility in his daily work. So in order to shoot a radius, the first thing we had to do was turn a foot on, and then you go from the master switch to the first foot. So let's say I'm going to shoot an 8-foot radius, right? It's very important that I count the switches to keep track of where I'm at while I'm shooting the radius, because half the time I'm looking out the window and I'm driving this truck. So master 1, 2, 3, 4, 5, 6, 7, 8, 7, 6, 5, 4, 3, 2, 1, master. Usually leave this one on because it was the first one I was going to shoot. It's always a good practice to leave your bar switches off. In the event that you accidentally hit the master, nothing will happen if they're in the off position. Especially when you're moving around and you're shooting radiuses. When you're shooting a lot of straight highway shots, it's not necessary to turn them off all the time, because you're not making a lot of big movements. You're usually just going from the master switch to the swing. One of the reasons that the bars swing and raise are positioned the way they are is so that you can instantly go to the bar swing after hitting the master switch. This is extremely useful when shooting next to curb and gutter. Usually ready to go. I hit my master switch, I can go right to my swing. Okay, move in or away from the curve. Avoid painting the curve. So master swing. Master. Okay, we're going to talk about the Sauer Danfoss portion of the eTack. Very top of the display is volts. This is how many gallons is in the tank. Gallons per square yard, feet per minute, gallons per minute, width. This is the valves that are on and off on the spray bar in terms of the taper cut. Recommended nozzle size for the current spray pattern, that is, as you're spraying, the the computer's going to determine the nozzle size by the speed you're going and how much pressure is developing in the bar. So this is a recommendation. As you're spreading along and you've got number 2s in the bar and you look down and it says 3, well, it means it's recommending that you have 3s for that speed. So slow down a little bit and it'll switch to a 2, and you'll be operating within the right pressure range for the nozzles. This indicates if the heaters are on. If you have the option of electric heat, this will show you when they're on. With electric heat, this shows the temperature of the tank, and this shows the temperature desired, so it's like a thermostat. If you want it to heat to 156 degrees, you can set that and it'll maintain 156. Gallons used, that's how much you've sprayed out of the truck. The lineal feet that you've spread, that's in feet. And square yards covered. Down at the bottom you'll see previous, select, edit, and next. Next changes pages, so we can cycle through all of the pages. Select changes the window you're operating in so you can make adjustments. Like right now, I can change the gallons per square yard by increase or decrease with the switch outside, or if I hit edit button, notice that my bottom display has changed. I got cancel, up, down, or down, up, and OK. Okay, I can move the rate up and down with this function. I can either hit cancel and get out of there, see it goes back to the other mode, or if I were to move it down or up, I can hit OK and it saves that rate. Hit select. I move down to my temperature, so then I'll go edit. Notice I have an up and down, so I can raise the desired temperature up. Let's say up to 161. Say OK. Hit select again. I move to the gallons used. Notice the little symbol next to gallons used. Select gallons per square yard. I press and hold reset. It'll zero everything. I hit select again and we're back to square yards. In the spray bar region, we have indicators for the taper cut. The little bars in the center of the squares represent a valve is on. On the right and left, the triangles represent the line markers. So as I turn the bar off from the left to the right, notice the little dashes disappear. The screen's not a direct representative of what's actually happening in the back. The valves are cutting off as fast as you pull the trigger, but the display is just a little slow. It's accurate, it just takes a second to get there. So notice I'm turning them all the way back on. Same with the right side. I want to turn it off from the right to the left. I can taper it off just by hitting this switch. Each click represents a foot plus at the end the line marker. So I turn them all the way back on. As far as the manual switches go, they're not indicated on the screen. That only indicates the taper cut. The manual switches are indicated by their visual presence, so you want to look at them and see that they're on or off. Now, if these switches are off, they won't come on when you hit the master. Both of Both have to be on in order for a valve to come on. So the taper lock has to be on, and the lower valves have to be on, and then when you hit the master, all will come on. So if I have these shut off with the manual side, and I turn a few off with the taper cut, the only ones that are going to come on are the ones where both switches are turned on. So these three on the left side of my bar aren't going to come on, and then the taper cut has shut off those on the screen. Even though the manual switches are on, they're not going to come on. All have to be on. Feet per minute is feet per minute shows your ground speed. Gallons per minute shows the rate at which your pump is turning. And the width is the width selected. Now notice that I have all my switches on and it only shows 8 feet. That's because my wings are folded up. If I fold my wings down, all of a sudden I just added 3 feet on the left side. Fold my wing down on the right side. The limit switch actuates, and all of a sudden I'm at 14 feet. So this shows you your current width at all times. Next page, notice the meat. Meat is a future application where it hasn't been developed yet. I'm going to hit select, and I'm going to shade the idle position. Idle is the circulate speed. That's the speed the trucks circulate. Anytime the master switch is off, the bar goes into circulation mode and it circulates at whatever idle speed you have selected. We can edit this. We can change the idle speed up or down to the desired rate. Press OK, and then that's your circulate speed. If I hit select again, I'm going to go to simulate feet per minute. In a diagnostic stage where you needed to simulate feet per minute in order to test other functions with the computer, this is what you'd use. If I hit edit, I can change the simulate speed up and down. I can run it up or I can run it down. I can press OK. Hit select again and my little symbol moves to simulate FPM off. Simulate feet per minute should be off in all normal cases. The only time you ever want to simulate feet per minute is a diagnostic stage, or if you had a FPM sensor fail, you could simulate feet per minute. Note that you're going to have to figure out how to drive exactly that speed to get the rate, but you could do it. So off is the normal position. If we want to turn it on, notice the on and off button. We can turn it on. Now it thinks it's going 300 feet per minute. I'm going to turn that back off. I'm going to hit select. Now we have simulate gallons per minute. We can actually control the pump speed right here in simulation mode. So if I hit edit, I can change the simulate pump speed up or down, whatever gallons per minute I desire. Say OK. And then the next position, I hit select, I can actually turn it on or off. Off is the normal position. You don't want simulate gallons per minute running when you're trying to shoot specific spread rate, because it's only going to turn at 21 gallons a minute. So I'm going to turn that off. I'm going to hit select. It brings us over here to manual pump speed. In this switch right here, CRC and manual, if I switch to manual, it's going to run the pump speed at 100 gallons per minute. We normally leave the manual pump speed on. That way at any time, let's say you have a plug nozzle, you can put your pump in reverse, switch it to manual, it'll instantly go to 100 gallons a minute and suck the asphalt back while you go unplug the nozzle. Go back to CRC, pump forward, and then you'd be back to CRC mode. If I want to change the manual speed, I hit edit. Same again, up and down. I can run it up, I can run it down. Whatever speed I want, say OK, and it's saved. Push to select, it goes to flush time. Earlier we talked about the flush switch. So if I were to switch this to flush, and it goes into auto flush, and we cycle our pump, it's going to suck, or it's going to blow the asphalt out of the bar, and then the time that it actually circulates the, I'm going to turn this off so we can see the display. The time that it actually circulates the diesel is right here. So right now the flush time is 4 minutes. So it'd circulate diesel for 4 minutes before it put it back into the flush tank. So if we wanted to change that flush time, and if it wasn't flushing the bar good enough, so run her up to 10 minutes. So it's, then it'll circulate diesel for 10 minutes and flush the bar that much longer. Hit select again. We're at contrast. We can control the contrast of the screen by running this number up and down. Next page, FCal. That's footage calibration. We drill and tap the rear end of the truck. We have a sensor that reads the teeth of the ring gear as they move by. Different trucks have different size tires and different gear ratios. So we have to have a calibration number to make the footage right. Typically, you you measure out 1,000 feet. At the start of the 1,000 feet, hit your master. Drive the length of the 1,000 feet, and right at the end of the 1,000 feet, shut it off. It'll come up with a measurement. Okay. If we want to edit the FCal, we hit edit, and then we run the number up and down, and then make the footage read 1,000 feet. If you run this up or down and go back to the first page and look at your footage after you've driven 1,000 feet, let's say it's off. So say it read 1,035. So you run that number down and go back to the first page, and it'll show a different footage number, and you keep doing that until it says 1,000 or whatever footage you measured out. Say OK, and hit select. GCal, same thing. GCal is for the gallons calibration. Different size pumps require different GCal numbers. If your pump were to start to show some wear, you might need to increase the GCal number to make it pump the right rate. This is not uncommon, and different materials can have the same effect on a GCal. If your GCal is a certain percentage off, then change the GCal by that percentage and it should come out right. Hit select. TCal is the temperature calibration for the tank. If the temperature's not reading right on the display as to what the actual temperature is in the tank, you can calibrate that. These numbers are 1,000 is basically 100%. Imagine a decimal point on the first number. Hit select. Line markers are on. This is a setup option. When you first build a truck, you may or may not have line markers. If you were to turn the line markers off, they won't be available on the first screen. And hit select. The width of the bar, we build different width bars, so this is how we tell the computer how wide the bar is. Hit select again. Auto shutdown mode is an option that shuts the computer off after it sits idle for 15 or 20 minutes. This can be, if you're heating, then you need to leave this in the off position because it'll shut down on you. Hit next page. Hit next page. This is our motor diagnostic page. Most of these numbers are for in a factory evaluation. Over the phone we may ask what some of these numbers read. The next page is a switch page. This page is a diagnostic page to determine if your switches are faulty. Each one of these switches represents a switch on this control board. If you think you're having trouble with the switch, you can use the switch diagnostic page to determine whether the switch you're operating is faulty or not. The switch on the display should represent the position of the switch on the console. We're preparing to load the eTack with asphalt. With my face shield in place and heavy gloves on, I remove the load hose from the trough. Load hose is already hooked to valve A. Remove the cap and connect to the distributor. In this video, we're just simulating loading the truck. We're not actually loading it. We use Dixon nuts on the load hose because Dixon nuts are much safer than cam locks. I connect the load hose to the distributor. Tighten the load hose. And put the pump in forward and stroke it to approximately 250 gallons a minute. Open valve A and you should see the hose move, and it should start sucking asphalt. At this point, we would open the transport valve. It isn't shown on the video, but as we start sucking asphalt when filling the tank, the transport valve has to be open. Keep an eye on the float gauge. Watch the tank as it fills up. At the end of the cycle, we're going to close the valve on the distributor or the transport. I'm going to slow the pump down to about 40 gallons a minute so I can maintain suction. With a Dixon nut, one of the real safety factors is I can loosen the nut slightly and wiggle it just to see if I can hear a suction noise. If I get asphalt squirting or leaking out of the Dixon nut, then something's wrong. I slowly disconnect the hose. I should hear a suction noise the whole time because the pump is still running in forward and valve A is open. I lift the hose up and suck the remainder of the asphalt out of the hose. Let it drain into the pump. We're still pumping in forward. At this point, I'd like to put a little diesel or flush fluid or even WD-40 on the cap just to keep it free of asphalt. Put the load hose back in the trough. And close valve A. At the end of the cycle, shut the pump off. De-stroke the pump speed knob, switch the selector to cab control, and you're ready to shoot.